Well, hello and welcome in distance learning land to your notes or math help, whatever you want to think of it as, for lesson 92, which is about stoichiometry. Now, again, stoichiometry can be a little bit mathy, but I'm hopefully going to give you some tricks which make it a little bit easier to deal with, as long as you understand some of the concepts behind stoichiometry. It's really easy. It follows a lot of the stuff we've been talking about here in chapters 13 and 14. Um, but stoichiometry and 15 and stoichiometry is essentially just this idea is if we have some chemicals, we're going to put them together. How much are we going to get out? And if you understand the basic concepts behind finding molar mass and things like that, usually it's not too difficult. But if you've had some problems with that in the past, you may have a little bit of problems here now. So anything you can do to go back, review chapters 13, 14, and 15 will probably be pretty helpful to get you through 17. So anyway, the first thing that we want to remember when going through stoichiometry problems is that we have to be in moles. You cannot ever solve a stoichiometry problem in grams. You have to convert out of the grams and into moles. Now, there's a couple of problems. The problems could be given to you in atoms or molecules, but you just don't see this too often. You don't see, you got 3 atoms of this and 2 atoms of that reacting together. What happens? Okay. Basically, we don't think in terms of individual molecules when we talk chemistry. They're just, it doesn't happen because we can't get those kind of quantities together. It's too small, it's too tiny. So, a way to replace molecules or atoms is through through grams or the moles. The moles direct conversion. It works nicely, but the grams again don't. So you might see 6.02 times 10 to the 23rd molecules of this react with 1.2 times 10 to the 24th molecules of this. It's just not very common. Okay, it can happen. You just have to think about, well, how many moles would 6.02 be times 10 to the 23rd? And how many moles would 1.2 times 10 to the 24th atoms be? It's going to be easier to deal with it in those terms. So anyway, we do see problems very frequently. There's 3 moles of this reacting with 10 moles of that. What are the products that show up? Those are relatively easy. We're going to do one of those right here. But then there's also problems where I've got 19 grams of this and 30 grams of that. What kind of products do we get? Those are a little bit tougher. Take a extra step or so to find out exactly what's going on there, but they're doable. Now, the book in lesson 92 talks about going through this mole tunnel. Now, if that visual helps you with doing these problems, great. I never learned the mole tunnel thing. It makes sense to me because I've been doing chemistry for a long time. But I think I have a way that will make your lesson 93 stuff easier. So I'm going to teach you it that way. If you want to use the mole tunnel, by all means, use the mole tunnel. If that's helpful for you, do it. But hopefully, when you look at my way to do it, you go, oh, wow, I don't have to worry about this mole tunnel thing. I can see what Mr. Wire's trying to do here. And if it makes sense, go for it. If it doesn't, try sticking with the mole tunnel. Ask questions till we do get it worked out. So anyway, let's take a look at the problems here. The first one, this was your chem catalyst. Just said, hey, I've got 3 calcium chlorides plus 2 sodium phosphates react to make a calcium phosphate and 6 sodium chlorides. Again, this is 2 aqueous solutions coming together. Again, it's going to mix up in our belly and our gut, and it is going to then be processed in our bodily systems to create calcium phosphate, which is what makes our bones. And so this calcium phosphate solid precipitates out into our bones, hopefully, and we get nice, strong, healthy bones. And then we also have some salt running through our system aqueously, and that will just eventually be peed out in our bodily processes. But the question we have first is how many moles calcium phosphate would we make if we used 6 moles of calcium chloride? And so the idea here is you want to look at your mole ratio. And so if we start with our mole ratio, we have 3 calcium chlorides, we have 2 sodium phosphates, making 1 calcium phosphate and 6 sodium chlorides. So again, this is one of those where I said math-wise, sometimes chemistry doesn't make sense. 3 plus 2 makes 1 plus 6. 5 doesn't make 7. And it doesn't have to in chemistry. What we have to remember is that the left-hand side has to have the same number of calciums as the right-hand side. The left side have to have the same number of chlorides as the right side. The left side has the same number of sodiums is on the right side. The left side has the same number of phosphates is on the right side. That is the key to the math of chemistry, is that you have both sides have the same amount. It's a balanced equation where making sure that the law of conservation of mass is being kept. So the idea here in this question just says, hey, I've got the 6 moles of calcium chloride. So that's that guy right there. Now, in these problems, oftentimes you won't see the second compound being mentioned. And so in that case, you have to imagine that you have plenty of it. And if you have plenty of it, you just have more than enough. And so if you want to put something here like infinity or whatever, you can, but just know that you don't have to worry about the sodium phosphate amount. Now, when we get into less than 93, we do have to worry about it. But for less than 92, I don't think we're worrying about it too much. So if we have 3 to 6, and we want to know how many of these guys we're going to make, what I do is figure out, well, how do I go through either multiplication or division from 3 to 6? And so how do I go from 3 to 6 is I multiply by 2. And so 3 times 2 gives me 6. So what am I going to have to do to this one? I'm going to have to multiply it by 2. And so I'm going to get 2 of the calcium phosphates by using 3 of the calcium chlorides. Okay. Now, the next question is, how many moles of calcium phosphate can be made from 111 grams of calcium chloride? Well, when we go to the calcium chloride, what we have to think about is how much is that? How much is 111 grams? We cannot use grams. I can't plug in 111 here. Okay, I cannot do that. So I can't go 3 times what gives me 111. 1 times that same number gives me the answer for calcium phosphate. It does not work because calcium phosphate and calcium chloride don't have the same molar mass. So what do I have to do? Well, calcium is 40. Chloride, there's 2 of them, times 35.45. That is 70.9. So 40 plus 70.9 is going to give me 110.9. I'm not going to mess around with 110.9. I'm going to call that 111. And so what I have here is 1 mole. Now, I go back up here to my mole ratio. This time I have 1. So what do I have to go from 3 to 1? Well, I can divide by 3 or I can multiply by 1/3. Whichever works best for you, do it. I'm going to say let's divide that by 3. And so what I have to do over here is I have to go 1, divide that by 3, and that's going to give me 1/3 of a mole of the calcium phosphate. So the answer to that one would be 1/3 mole. Very frequently, what you will get is a question is not how many moles, but how many grams of calcium phosphate can be made from 111 grams. At that point, what you would have to do is figure out, well, what is the molar mass of calcium phosphate? Multiply it by this 1/3 moles, and that would give you the number of grams. So we'll go to the check-in and we'll finish this up. All right. So for our check-in, at the end of the section here, the end of the lesson, it wants to know how many grams of magnesium are needed to make 190 grams of magnesium chloride. And so the idea here is, again, we've got to look at our equation, our chemical reaction equation, what's happening here. And I've got magnesium solid. I throw it into some hydrochloric acid. Basically, what it's going to happen is it's going to start to bubble. It's going to bubble pretty rigorously. You got to be very careful with this reaction. You get any kind of flame going near it. If it's too warm, this will actually explode on you. So you got to be careful. But that's going to make some magnesium chloride, and that's going to be aqueous. It's going to be in solution. It's going to bubble again, this hydrogen gas. So the first thing you want to do in any one of these problems, figure out what your mole ratio is. So mole ratio here is 1 to 2 makes 1 and 1. So again, math-wise, doesn't make sense. 1 plus 2 does not equal 1 plus 1, but it doesn't have to because this is chemistry. And so what we have here, again, is a balanced equation. We've got the same number of chlorines on the right side of the equation we do on the left. We got the same number of magnesiums on the right that we do on the left. We got the same number of hydrogens that we have on the left compared to the right. So anyway, once we have the mole ratio, we got to go over here and check out what the problem is. Okay, I've got this 190 grams of magnesium chloride. How many grams of magnesium are needed to do it? Well, what we have to do, we cannot do this in grams. If I do it in grams, I'm guaranteed failure. So I've got to swap over to moles. So if I look at this, 190 grams. Well, magnesium is 24.3. We have chlorine, 2 of them, times 35.45 should give us 70.9 plus 24.3. And so basically what we end up with here is 95.2 grams per a mole. Well, if I take 190 grams, divide it by 95.2 grams per mole, I get just about exactly 2 moles. I'm going to make the math easy on myself here. If I call this 2 or 1.9, whatever, it's going to be just off of 2, but a little below. It's just going to adjust my numbers slightly. We'll call it 2. It'll make the math easier to do, in our heads. So what I have here is 2 for that guy. And so what would I make here? What would I make here? What would I make here? Again, how do I go from 1 to 2? This is that mole tunnel ideal. idea. How do I go from 1 to 2? I'm going to multiply by 2. So each one of these is going to need to be multiplied by 2. Again, it doesn't specify anything about how much hydrogen is there or anything like that. So I don't have to worry about it. Just assume it's going to be plenty, but 2 would be there. Then I'd go here times 2, here times 2, and I would need 4 moles of the hydrochloric acid, and I would need 2 moles of the magnesium. Now, I can't stop here because what did the question ask? It says how many grams of magnesium are needed. So an answer of 2 grams would be incorrect. Okay. You have 2 moles, but now you've got to figure out the number of grams by multiplying by 24.3 grams per mole. And 2 times 24.3 is 48.6 grams of magnesium. I could figure out, okay, 2 times 2 here, I would make 4 grams of hydrogen gas. I would go 36.45 times 2, so somewhere around 72.9 grams. If I were to do both of these sides, what I should see is the amount on the left should add up to the amount on the right. And if it doesn't, something's goofy. I've messed up somewhere. So it's really important that you go back sometimes, you check that out. Oftentimes it's like, oh, bing, there it is. There's the answer. I just messed up on the number of grams because, again, conservation of mass tells me whatever's on the left should equal whatever's on the right. So anyway, at that point, I hope that makes sense. If it doesn't, you guys know it. It's T. Wyrick at auhsd.net. Email me. Let me know if you have any questions, and we'll get through it.